Alright, so for this video, I chose to reassess G2 and G3. So I'll start out with G2, and we'll slowly move into G3. So for G2, I drew a simple problem here. We have a ball rolling on a flat surface, no friction involved, rolling to the right with a constant velocity. It obviously is 1 meter per second. So G2 is reporting data and calculating answers with a reasonable amount of precision. So I would assume that is mostly dealing with tables. So I'm gonna fill out my table here. And our position is also going to be 0, and then we have 1, 2, 3. So I have a table demonstrating time versus position. So at the 0 second mark, the ball is not moved. At the 1 second mark, the ball is moved 1 meter in 1 second. So 1 meter per second, obviously. Alright. So I don't know if there's anything else to G2 than that. I would assume that's it. That's pretty precise if you ask me. So G3, I am going to add in a graph because it just makes more sense. Our graph is going to look something along the lines of this, maybe. We have a y-intercept of 0, so our points are going to hit at every second. Position versus time, they're going to cross at every second. So there's our graph. It's pretty simple. For these little notches right here, we would have 1, 2, 3, and also 1, 2, 3, but I didn't put those in. But and our 0 would be at the bottom corner. So main part of G3 is developing and explaining a mathematical model for our linear relationship. So here I wrote down the basic equation for mathematical models, and we're going to expand on it, put it more into a physics idea or whatever. Alright, so our y is going to be our position. So here I would write position equals mx, that is going to be the slope times the time. So then we're going to have in parentheses 1 meter, let's space that out, 1 meter per second. So it's going to be 1 meter per second, and we are going to multiply that by time, because this is our x, so we have to match equation with equation. So I'm going to multiply that by time, and our y-intercept, which is the b in this equation, is going to be 0, because as you can see on our graph, there is no y-intercept. The ball starts rolling at a constant velocity as soon as the time starts. So however that works. But that is a very basic equation. Maybe there are things that we can add in here that maybe would clear things up. Since this graph is already linearized, we do not have to square the y or the x axis, so you're not going to have any extra units adding on to your y or your x values. So that would basically be our, forgot something, there we go. That would be our, that'd be G2 and G3 for you. That is very basic. I don't know if you maybe want to, like, set me up with something more challenging, but that was basically just explaining my understanding of G2 and G3 in a very broad spectrum. Alright, well, that's about it. Thank you.